Hey guys, this is day 2 of 100 days of DSA challenge, and today we have the question next greater element. So not gonna lie, this question took me a lot of time to solve, but I'm glad I solved it, and here I am with the solution. So let's understand the question first. Uh, this is kind of complicated to understand it first, so let me just use a whiteboard and explain it to you with this test case. So basically we have two arrays. One is nums1 and it has like the elements 4, 1 and 2. 4, 1 and 2. And this is the nums1 array. And we have another element nums2 1, 3, 4, 2. 1, 3, 4 and 2. Well, this video is going to be a little long because this question is a little complicated to understand. So this is our nums2. So basically we have to find the next greater element in nums2, and we only have to find it for the elements in nums1. What did I just say? So first let's just find out the next greater element for all these elements in nums2. So for this one, what is the next greatest element? Okay, so it is 3. I can see that 3 is the next greatest element for 1. Now for 3, what is the next greatest element? It's 4. For 4, what's the next greatest element? There's no next greater element, so we will return -1. In the question it is said that if you cannot find the next greatest element, you have to return -1. And for 2, what is the next greatest element? Well, obviously 2 is on the rightmost side of this array, so there is no next element, hence no next greatest element. So that's it. That's the next greatest element array for nums2. Now this is not the final answer. What we have to find is the next greatest element for these. In the question it is given that nums2 is a subset of nums1 is a subset of nums2. Hence all these elements in nums1, they are already in nums2. So we have to find the next greatest element of this in this array, right? Basically for 4 it will be, what did we find? For 4 it was -1, so -1. For 1 it was 3, and for 2 it was -1. So this is the output that we desire, as you can see here. Right, so how to solve this now? I hope you understood the question. Now I solved it first by myself by the naive approach. Okay, so now let's try to understand the code with the help of this example. So we have taken a stack st. Let's say this is the stack st. And we have taken a vector vector of the type integer. The name of the vector is answer. It is of the size nums1.size because that is what is required, as you can see. And we are initializing all the elements of answer of ans with -1, and then we are taking an ordered map integer comma integer type. So now we are iterating from the back. This is the loop for that. We are iterating from the back of nums2. So in this particular example, this is nums2 and we are iterating from the back. So now currently we are here, and then element is nums2's ith element. Basically this, the current element, it is the element in this case. Now there can only be 3 cases. Either the stack is empty, or the top of the stack is greater than element, or the top of the stack is less than equal to element. So in the first case, obviously stack is empty. So what do we do when the stack is empty? When the stack is empty, we simply push the element and we continue. By continuing, we are just moving out of this iteration and going to the next element. So therefore we are pushing 6 into the stack now, and we move to the next iteration. Basically we continue. So we are at 4 now. So now let's check the condition. 4 is the current element and 6 is the top of the stack. So 4 and 6. So basically the current element is less than the top of the stack. Which condition does it satisfy? The element is less than the top of the stack, this condition. So what do we do in this condition? If the top of the stack is greater than the element, then we map the element to the stack's top. Basically we are using the map to stack the element, the 4, with the stack's top. Basically it will now store like 4, 6. I apologize for this. Let me just turn off smart drawing. So it will basically store like 4, 6. So 4 is now mapped with the element 6. Okay, and then we push the element into the stack and we continue. So we push the element 4 into the stack and we continue. We move to the next element. Now the element is 2. Which condition does 2 satisfy? Again, the top of the element is greater than 2, right? 4 is greater than 2. So we will 4 is greater than 2. So now we will again map 2 with 4, right? We will map the element with the top of the stack and then push the element into the stack and we continue to the next element. And now we are at the element 1. Now 1 again satisfies the same condition, hence we push 1 into the stack and we map 1 with 2. So guys, what we are storing in the map is basically the next greatest element for this element. So we are basically saying that for 4 the next greatest element is 6, for 2 next greatest element is 4, for 1 next greatest element is 2. Okay, so now we move to the next element 3. Now let's see, 3 does not satisfy this condition. 3 satisfies this condition. The element is greater than top of the stack. Now what do we do in this condition? Basically we will keep popping the elements until we find an element greater than 3, which will be the next greatest element for 3. Did you get it? So we have 3 right now, but 1 is not the next greatest element for 3, so we will pop it. 2 is not the next greatest element for 3, we will pop it. 4 is the next greatest element for 3, so hence we will stop at 4. So let's see. So you see that this thing is like a loop. Okay, we have to pop again and again until we find an element greater than this. Okay, so while the stack is not empty and the stack's top is less than equal to element, we will keep popping the element. We will keep popping the top of the stack. Okay, and now after we are done popping the top of the stack, so in this case 1 and 2 are popped out and now we are at 4. So if the stack is not empty, okay, the stack is not empty, then we will map the element to the stack's top. Why? Because we have found the next greatest element for 3. So we have to map it somewhere to note down the next greatest element for 3, right? And then we move to the next iteration, which is 5. Now 5, okay, and we are also pushing it, my apologies. So after popping them, we are pushing 3 into the stack and now we come at the element 5. Now 5 again, it is greater, so we will keep popping until we find a greater element. So we pop 3, we pop 4, 6 is greater, hence we stop at 6 and we push 5 and we map 5, 6. So now we have found the next greatest element for 4, 2, 1, 3 and 5. 4, 2, 1, 3 and 5. And we did not find the next greatest element for 6. And you can say that in the vector we have assumed that all the elements are -1 by default. So hence in this loop we are going to I'll show you how it works. So basically we are iterating through now nums1 dot size. See, till now we were only dealing with nums2, but now we are dealing with nums1 also. So for we will iterate through nums1, and if map dot count, see this function map dot count, it is used to check if the element exists or not. This checks the key, okay, the key of the map, and does it exist or not. So it will check if the key of the nums1 ith element exists. Means that currently, say, let's say we are at 4 in this case, right? Or let's just stick with our example. Let's say that for this nums1 was 1 comma 2 comma 5. Okay, let's say that. So now we will check for 1, does 1 exist in our map? Okay, so what was our map? Our map had the elements key comma value. What were the elements? 4 2 1 3 5. 4 2 1 3 5. And what were the corresponding elements? 6 4 2 4 6. 6 4 2 4 6. Right. So now this map.count function will check in the key, that does the element exist in the key. So now does 1 exist in the key? Yes, it does. If it does exist in the key, then we are writing answer's ith element, basically the vector's ith element, will be replaced by the value of the map at that particular key. So now okay, for in this case our answer vector, what would it be? Our answer vector would by default be -1 comma -1 comma -1, because it is the same as num size, right? But now what we are doing is that does this one exist in the key? Yes, it does. Then map the value of this into this, replace the value of this into this. So now instead of -1, it will be 2 here. Then it will check for the next element, that does 2 exist in our map? Yes, it does here. Hence replace this by its value 4. So we will replace it by 4. Similarly, check for 5. Does 5 exist in this map? Yes, it does. What is the value? 6. Replace -1 by 6. And we are done. This is the answer. Now let's say if we had 6, if we had 6 in nums1, like here, if we had 6 here, then there would have been no change in this by default -1 here, because 6 does not exist in our map. Hence it will have the default value -1 which we initialized. Well, I'm sorry for the explanation if it was not very clear, but I tried to explain in depth with a test case that how this problem will actually work out. So thank you guys for watching, and let me show you that this code actually runs. It solves the test cases. Right, and we can also add a custom test case here. It was 1 2 5 6, and our nums2 was 5 3 1 2 4 6. 5 3 1 2 4 6. Right, so if I run this, my answer should be 2 4 6 -1. Let's run this. and as expected our answer is 246 minus 1. So that's it guys, thank you for watching. I hope you understood the explanation.